Kia ora koutou. This is part 2 of a very, very slow and quite boring video about how to do graph transformations and how to describe them. So we're down to the last part of this question where we have to take this function, the one that we graphed in the first part, and we have to describe how we would get from here to here, and then separately how we would get from f of x to h of x. Where I got to at the end of the last video is I talked about how we could do the first transformation to get from f to g. Right, and that's the trickier of the two. And we're going to use the terminology that we're stretching f of x when we've got f of kx. What we're going to say is that we've got to stretch in the horizontal direction or in the direction of the x-axis by a scale factor of 1/2. So it's quite easy to screw this up. So I want to talk about what we've got a little bit more. If we've got, suppose we've got f of 3x, then why is that a stretch by a scale factor of 1/2? Well, if we go to the most basic function we can think of, which is probably f of x is equal to x, then if instead we do f of 3x, then I think when we first start out thinking about graphing, most of you are going to think about that as a vertical transformation, and we can do that, but when we're working with the trig ones, it's much easier to describe it as a horizontal stretch with a fractional squeezing, right? So here's my y equals x, and here's my y equals 3x. So in here, we can describe it as a stretch in the y direction with a scale factor of 3, or we can describe it as a horizontal stretch with a scale factor of 1/3, right? Because every x value is getting pulled back. Every x value is getting divided by 3. In other words, to get a particular value of y here, we need 1/3 the x value that we would have needed before. So in general, if you've got f of k of x, you can describe that as a stretch in the direction of the x-axis. You might want to say in the positive direction. With a scale factor of 1/k. So now let's go on and have a look at how that helps us do the second part. Oh, so we haven't done the +4. Well, the +4 is very easy, and I think is the easiest one for students to get when they start doing these. What the +4 does is it moves every y value up by 4. So the best way to describe that, so we've got for g of x, we've got our first description, which was our horizontal stretch by the scale factor of 1/2, and then we've got a translation. So we're going to translate f of 2x by the vector 0, 4. So that's the clearest way to describe that shift. The other language you could use is you could use a vertical shift of 4 units in the, we can't just say up, right, in the positive y direction. Okay, something like that. But I think it's cleanest when you're doing these ones to talk about a translation and to give the translation vector. All right, now let's look at how we can get from f of x to h of x. So f of x is blah, 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 and now this is 2 times f of x plus 1/2 pi. So we had f of x, and then we had f of x plus 1/2 pi. Now, if we think about what happens when we've got y is equal to x squared, and going back to like year 10, when we moved that to y is equal to x plus 2 squared, what we've done with that is that every x value has shifted this way by 2 units. So when we've got this function here, it's the same idea, right? Every x value is going to get 1/2 of pi added onto it. And that means that my graph is getting shifted that way by pi on 2 units. So when I'm working with h of x is equal to 2 times f of x plus 1/2 pi, so h of x is equal to 2 times f of x plus 1/2 pi, then the first thing that's happening here is that we have got a translation of f of x by this vector, negative pi on 2, 0. Or we could say that we have shifted f of x, pi on 2 units, to the left. But we have to say which way we've shifted it. So we want to say something like parallel with, or parallel to, the x-axis. But again, I think it's easiest to use this language here, that we talk about a translation and then we give the translation vector. Okay, so that's the x direction of the vector and that's the y direction. And the second transformation that's happened here is that we've got a stretch. So the second thing is we've got a stretch, and it's what we think of as a vertical stretch. So it's a stretch by a scale factor of 2 units parallel to the y-axis. And that's like what we had in the very first question, where we started with y is equal to cosine of 2x, and then we had y equals 3 times cosine of 2x. And that pulled all of my values up from doing a graph like this to doing a graph like this. Okay, all right, so that's all for now. If you've got any questions on these or you want some more practice, just shoot me an email or Mr. Hawk. Okay, thanks for watching. I'm going to do a question that Zachary has sent in next on sequences and series.